integration and differentiation is used to get equations that we can use to solve for gradient of curves. A curve, usually something like this. You have that, then that, and then there is a curve like this. Now, here's an example of a curve. If you're asked to find the gradient, the slope of this curve, you need a point, unlike straight lines that have this form. For straight lines, you just have a straight line, and however you calculate for, forgive my lines, they're not straight, however you calculate for the slope, it's always the same, no matter the 2 points you take. In this example, this point and this point, these 2 points are what I mean by 2 lines you take. Okay, but for curves, the gradients keep changing. If you cut from here, if you want to get the gradient at this point, you need to rule a straight line that would just touch that point slightly, still not straight, something like that. Okay, and then you want to make sure that it's just touching the point before you now calculate. You now take your, y2 minus y1, all over x2 minus x1. Now, if you want to calculate the slope or the gradient for another point, you need to go back there, draw again, do that again. But differentiation helps you tell this without plotting. Okay, you just differentiate the equation of this curve. When you differentiate the equation of this curve, you are going to get an equation that acts like a formula, a custom formula, specially for this particular curve, not for every curve, just for this curve. Whatever you get after differentiating the equation for a curve, it's like a formula for gradient for that curve. So you just fix in values, all right, into that formula. You are going to get the gradient for that point, the point of those values you're fixing. Okay, now this question here tests your understanding of differentiation and its application in telling gradients of curves. Now, the gradient of a curve is given as this. What this means is, this curve, normally curves are power 3 and the likes, power 2 and all of that. Now, this curve has been differentiated and this was obtained. And then an extra information that is actually needed is that that curve passes through a point 2, 1. So one of the points that curve passes through is 2, 1. Like this could be the point 2, 2, 0, sorry. So somewhere around there, let's say this is, that cannot be 2, 0. The 2, 0 is somewhere up there because the 2 is x and then the 0 is y. So 2, 0, let's say somewhere here. All right. So we're informed that one of the points this curve passed through is 2, 0. Now, how can we get the equation of that curve? It's very easy. Integrate this backwards. Integration is like backwards of differentiation. Integrate this. Go back. You're going to get the equation from which this was obtained. Okay? Very easy. When you get that equation, of course, there will be a constant plus c. All right? Now, put in these values as x and y, and then find c. Then rewrite your equation with c. That's all. All right, let's do it. We have 2x plus 7. Let us integrate this. All right. Now, I'm going to give you a little head start. We have 3x raised to power 2. We want to differentiate this. We'll multiply 2 by 3. We'll get 6. And then we'll write down x and say 2 minus 1. That's just the way it works. Just subtract 1. Of course, 1. So I'll put that down for learning sake. So I'll just write 1 down there. So if we want to go back, we start from the last thing we did. The last thing we did was I added 1. So this time around, we are going to, we subtracted 1, sorry, that was the last thing we did. So now we are going to add 1 first. When we add 1 to 1, we get 2. Then we divide by 2. So 6 divided by 2, we have 3, then x with a 2. So we are back here. You see, this takes us back here. So that is what we're going to do. We're going to start by adding 1 here. So 1 plus 1, 2. Use it to divide these 2. 2 divided by 2, 1. So we're writing x power 2. Alright? Plus, now, when you say a constant like this, it was actually like this. And after you say 1 times 7, you get 7. Then 1 minus 1, 0. So you have x raised to power 0, which is 1. That's why you don't have anything here. Alright? So this is actually 7x. And anytime you integrate, you always add that constant c there. Okay? So we have, let me just rewrite that, 2x plus 2x squared plus 7x plus c. Now, as an equation for a curve, there would be a y here. So y equals x squared plus 7x plus c. Alright? Now, because it passes through this point 2, 0, we're going to put, this is x and then y. This is how it's written. So we're going to put 2 in place of x. So 2 raised to power 2, that's 4 plus, and then times 2 plus c. Y here is 0, as you can see. So we're putting in 0 here. Okay? So this is 14. 7 times 2 is 14. 14 plus 4 is 18. So 18 plus c. Okay? That's 0 on the other side. So c is minus 18. Alright? So the equation of the curve is, we'll just rewrite this, but we'll now put in 18 as c. Minus 18 actually as c. Alright? So have y equals x squared plus 7x minus 18. This is the equation of a curve.